I want to first say how grateful I am to be here today with all of you, just brilliant people, heart in the right place. I want to thank Ben and Daphne and the planning committee for having me here today. And actually, I want Ben to come out here because I want him to help me with some AI. Come on. Okay. AI and neonatology. So that's kind of how I feel. I think Ryan and others maybe in this room feel somewhat the same way. That we really need to start understanding that AI is here. It's something that's inevitable, and we have to start realizing how to use it as a tool. But first, I want to tell you a little bit about myself. When I call my son in Washington, D.C., I still use a landline. A phone looks like this. When I write my mother in Pensacola to communicate with her, I send a letter in the email or through mail through the U.S. Postal Service. When I do calculations, I pull out a piece of paper and use a pen. When I detect congenital heart disease, I use a stethoscope. Well, I don't do that. So, do you guys do this as well? Do you use pen and paper, use a stethoscope to detect congenital heart disease? Well, I'm sure you don't, and neither do I. So I use fancy technology that assists us in everyday communication, which really is our cell phone, send text, emails, call people. There's actually a built-in calculator. To detect congenital heart disease, we use all the technologies, ultrasounds, MRIs, cardiac caths, data that's coming from our physiological monitors, data from maternal records. That's how we diagnose congenital heart disease. We don't do it with one tool. So what I'm here to ask you all today, do you think AI will become a tool like that we use every single day? Right now, it's at the height of the hype cycle. So everybody's talking about AI. I'm here today talking about it. It really is at the top of the hype because of ChatGPT coming out in November of 2022. It really has caused a storm. But it's at the height of expectations. I'm a medical director. I don't actually start being involved in things until it's proven to be safe, and that would be over on the plateau of productivity. Why am I involved today then in something like this? Because we're up here, it's going to come crashing down until we figure out how it's going to help us in the care that we provide. Right now, when I talk with people, I hear a broad spectrum of people's thoughts about AI. One is that it's going to disrupt healthcare and be awful. On the other end, I hear a lot of people being exuberant, saying it's going to cure everything and help us do a better job. I think the truth is somewhere in the middle. We in healthcare have been involved in great discoveries. 1928, Alexander Fleming discovered penicillin. It probably has done some of the most to improve care for our patients in the world than anything else. So this graph shows when penicillin was discovered, when it was produced in mass quantities. When other antimicrobial therapy and vaccines came onto the scene, our mortality rate across the globe has decreased. Thalidomide, anybody heard of that one? It's not something that we use today, but it was commonly used in the 1960s for morning sickness. It caused over 10,000 babies to have significant birth defects, so it quit being used. It was mainly used in the UK and Germany. The light bulb. We're surrounded by light. These ones are brighter than I thought, too, by the way. But it wasn't just simply that we made candles better. Thomas Edison decided that sending electricity through tungsten filaments created light. So we didn't just make the candle better, we disrupted it, made something much more impressive and useful. So I ask you today, will AI be the next thalidomide? Will it be the next penicillin? Or will it be the next light bulb? So we'll talk a little bit about that today. How many of you guys think AI is new? It's not new. It's been around since the 1950s. A Stanford professor coined the term at a Dartmouth conference, actually. Machine learning's been around since the 1990s. Deep learning has been around since the 2010s, and the new kid on the block, generative AI, has been around since the 2020s. So pretty new. Have any of you ever used AI in healthcare? Most of the time when I ask, everybody's shaking their head no. You indeed have used it, but you didn't know it. So automatic interpretations of EKGs are a form of AI. So we have trained computers and programs to understand that when these black squiggly lines go across the red gridded paper, it gives us information about heart structure, heart injury, electrolyte abnormalities, medication toxicities, and conduction abnormalities. It gives us a lot of information. It's an automatic interpretation that comes up. But do we use it blindly and say that interpretation is 100% correct? No. We use it and know that it's actually can cause errors or be wrong. So this, I think, is a way that we should think about AI in healthcare. That we should say it can help us, but we can't trust it completely because with EKGs, we now know how to read them. We know the indications for them. We know the limitations. And that's how we should think about AI when it enters our healthcare space. So I really have done a lot of thinking and learning about AI in healthcare. And quite often I hear about healthcare data bias. Never quite understood exactly what that meant. So in the past few years, I've really tried to educate myself and understand what it actually means. So EKGs, I'll continue to use it as an example. So have you ever thought of this? Because I hadn't. If you get an EKG in a 16-year-old white male and a 16-year-old black male, does it give you the same information? No. There's actually an increased reading of left ventricular hypertrophy for black athletes than whites. And why is that? Well, because when we were developing the rules for these EKGs, the patient population that they were using and developing these rules on looked a lot like me, old white guys. So not a very diverse population. This is an example out of Stanford that looks at it even further and how AI is trying to be used to predict heart failure from just 12 lead EKGs. Fantastic study. They use 320,000 EKGs and then use an AI model to predict heart failure 5 years after that EKG. And what they found is pretty interesting. So this is a receiver operator characteristic curve. And what you'll notice on the figure is that most of those colored lines kind of stay up together. And they looked at different races and ages. But there's one line that kind of sticks out there, and that's the orange one. That's much lower. So the test isn't as sensitive and specific as it is for the other groups. Turns out that's a black woman that's younger. So EKGs have inherent bias that's built into them. Why is this an issue? Well, EKGs are starting to be used for a lot of things, and the abilities are being amplified by AI. So they're on our watches. There's AI-enabled stethoscopes. There's single lead ECGs that are being used in telemedicine. So the power of AI being combined with just one of our tools, EKG, gives the ability to detect race, gender, LV dysfunction, heart injury, silent atrial fibrillation, prediction of future heart failure. That's from one tool. Imagine if that bias just continues to get amplified. So in pediatrics, we're better, right? We're not going to have this problem. Bias won't be an issue. Well, that's not true, unfortunately, and maybe it's even going to be worse for us. So that's why we have to be involved. This was a study by investigators that wanted to simply see how often in our randomized controlled trials for pediatric patients was race and ethnicity identified in the study population. And from 2007 to 2020, of which there was about 405,000 patients, about 1,200 studies, only 43% of the studies actually included race and ethnicity. 2007, it was about 17%. 2020, it was about 75%, but we're doing better. So our AI models are going to amplify the data that we give it. So just imagine if this is the best data we have, it's our randomized controlled trials. It's our best data. Another example, so if we say, okay, well, we're going to prioritize the publications that have come out and say New England Journal of Medicine, JAMA, Nature, they're the top. So we're going to give them the highest priority when these AI algorithms are looking at them. So this is a publication from New England Journal of Medicine, 1996, that looked at the effect on mortality in very low birth weight infants in St. Louis after surfactant was widely distributed. They found a 42% decrease in mortality in white babies, no change in mortality in black babies. So conclusion, surfactant doesn't work for black babies? No, we know that there's social determinants of health that weigh in. There's demographic bias that weren't accounted for at that time. But if we use these AI models, it will only amplify some of these issues, and it's going to be a problem. So there's big issues with AI in healthcare. Garbage in, garbage out. I've already talked about the bias. The other thing about healthcare data, about 30% of it is mislabeled, incorrect, or missing. So we only have about 70% to work with. What happens when one of these AI algorithms causes an error, causes patient injury, harm, or death? Who's accountable? Is it the healthcare system that bought it? Is it the AI developer that made it? Is it the physician that used it? Is it the patient and family who went out on their own and purchased it? Don't know yet today. Explainability. Us clinicians are not going to use something that we don't understand the output, how it's generated, to verify that it's correct. Even the people that develop a lot of these AI models don't understand the output and how it gets there. So that's a big issue. And then, is it trustworthy? Is it accurate? Is the data that's going into it private and secure? We don't want our patients' identified data going out there. So with all that, do we even need AI? So let's just be done with it. We're doing great today, right? Well, I don't think so. I think we need it. So medical information is doubling at a rate about every month. So it's huge amounts of data. We're in a data tsunami. We're surrounded by data, but we're not using it as well as we could. We need AI to help us connect dots so that our data becomes information, wisdom, and provide insight so we have better care for our patients. This is, to me, kind of what the current state of healthcare data looks like, this garage. There's some things filed nice and neatly in boxes, probably good, well labeled, but it's hidden behind a bunch of junk and we can't get to it. So that's really our EHRs. Right now, we're only using 5% of our EHR data. 95% of it is sitting there. There are some patterns that could be recognized in our data that just sitting there that would help us care for our patients better. We need it to look like this. Garages that are clean, organized, but we need it to be in every house, in every community in the United States, in North America, across the world, for us to better use our data and take care of our patients. AI is here. It's not going away. It is inevitable. So how do we get to here with AI where we can use the data? First of all, the reason I use Ben as that example is sometimes that's what I feel like. I'm trying to get us involved because we need to be. This is a prime example of what I see. I read a lot of AI publications so I can learn. When I look at these, this is actually a great publication about an AI model that they state is going to be like a primary care physician. Great model. 30 authors, 29 of them are data scientists, 1 physician, no ethicist, no nurses, educators, administrators. This is all currently being run by data scientists. We're way out of the loop and we need to be engaged and involved. Microsoft has a 49% position in OpenAI, which created ChatGPT and others. Microsoft has partnered with Epic. So by those connecting the dots, I used to tell people about a year ago that this was going to be an issue. Well, it is. So Epic just had their annual user group meeting now about 2 to 3 weeks ago. They unveiled that they have over 100 applications of AI that's going to be available in Epic, all the way from coding, billing, all the way down to patient care, documentation, and so forth. So if you have Epic, you have these capabilities. Epic's in 65% of the healthcare systems in the US right now. There's 882 FDA-approved AI-enabled devices in the US today. 75% of them are in radiology, only 1 to 3% in pediatrics. We're being left way behind. So this is a big issue. Big tech, big data, government, AI developers are really running the show right now. Us on the other side being healthcare scientists, patients, families, staff, administrators, educators, and ethicists are kind of on the outside. We need this to be a continuous collaborative learning adventure to make sure that AI works for us and our patients. Right now, large language models have democratized data. So everything that's in the internet is now almost at your fingertips. 60% of the global population has internet access. It still leaves out a third, but 2/3 has internet information at their fingertips. It's a great resource. It will change medical education. It will disrupt medical education, probably education overall. It's going to be a capability of being an individual tutor, provide adaptive learning. There's gamification that will occur. Simulation will change dramatically with the use of AI. Augmented reality, virtual reality, simulated patients. Neonatology, I've been told, and I know, has great data. We have great data warehouses with Vaughan, CPQCC, CHNC, and others. So we have some national networks, the Canadian Neonatal Network as well. We're not using that data as well as we could. AI can be applied and help us, and it's really great at pattern recognition. So as an example, and this was shown yesterday by another speaker, our rates of BPD continue to climb. So over the last 10 years, our rates of BPD have only increased. And it isn't because we're just taking care of the smallest babies or the sickest babies. It actually is occurring at every gestational age. So each one of those lines, 24 weeks, 25 weeks, 26 weeks, 27 weeks, 28 weeks, all have higher rates of BPD. And that is because I don't think our definition is very good. Oxygen at 36 weeks, not good. NICU criteria, mild, moderate, severe, not very good. Jensen criteria, under evaluation. I think that we've oversimplified a very complex disease process, and we're not doing ourselves any favors to really understand BPD. I think there's multiple phenotypes that exist within BPD, and we haven't defined them very well. AI could help us because it's great at pattern recognition, and there's different approaches to do that. So then we could develop interventions at appropriate developmental windows to improve care for our patients, and this is just an example. Image-based specialties are going to change dramatically and already have, even if we don't really know it. Radiology, pathology, dermatology, ophthalmology. These deep learning algorithms and convolutional neural networks do amazing at image pattern recognition, well beyond what the human eye can recognize. So we're not being left behind in at least some of the studies. There's been this study in pediatric radiology that's been used to detect fractures in pediatric patients. It missed 8 fractures out of 182, had a negative predictive value of 99%, this AI algorithm, and it was better than the ED physicians. Not better than the pediatric radiologist or the peds ED folks or even a senior resident, but better than the adult ED physician. You might say, well, that doesn't really matter. Well, it does, because about 75% of our pediatric patients are cared for in adult emergency rooms every single year. So if we could improve their ability to detect fractures and other things, that would be a good supplement to their care. Retinopathy of prematurity, there's a lot of work being done in ROP, especially by the IROP study. So if you haven't looked at them, do so, because it's great for us here in developed countries, but I think really will extend out into developing countries, and maybe AI technology will actually help them more than us here in the US, Canada, and Australia. It's been shown to have pretty reliable diagnostic predictability, consistency, so inter-rater reliability of looking at the images is improved. And then it's being used for kind of telemedicine or remote ability to do retinal imaging and care. There is at least one pediatric FDA-approved application that I wanted to bring up, and it's in the detection of autism spectrum disorder. And what it does, the AI algorithm takes in kind of 3 data streams. One is a questionnaire that's filled out by the parents and caregivers. Second is filled out by the clinicians, and then third is a 2-minute video. This AI algorithm is quite good. It has a positive predictive value of 81% and negative predictive value of 98%. And the thing is, our developmental pediatricians, I don't know about you, but in our institution, they have a 9 to 12-month backlog. So if you have a child that you're worried about has autism, do you want to wait a year to see a specialist? This could really help the specialist and increase the throughput through their clinics. So this is where we are in the evolution of AI, pretty early on. But this evolution is happening so fast. And that's why I'm here today, to talk with you guys about being involved. I think that it's our professional obligation, because we're always centered on our patients. It's our professional obligation to become at least AI conversational, if not AI literate. I did it. I'm not a huge expert. I'm here today telling you that 4 years ago I knew nothing. I just kept hearing healthcare leaders talk about it and decided I better learn. And so I've been able to learn over the last 4 years. I'm at least in the near conversational area, now into the literate area. But you know healthcare better than the big tech folks, data scientists, and it's up to you to make sure that racism is understood when we're looking at this. So AI does not stand for artificial intelligence, it stands for augmented intelligence. Only you are gonna help us decide if AI is like thalidomide, if it's like penicillin, or if it's like the light bulb. We're on a journey of 10,000 miles. I'm just encouraging you to take at least one step into that journey with us. Thank you.